In this video, we are going to talk about the one-sheet hyperboloid. So let's talk about how to pick it out, given that we're going to have to recognize it to be able to graph it. So this has one negative. All right, so that's talking about that, one negative. They all have power of 2. They all have power of 2. And then the third thing is that there's a constant, the 1. Okay, so this tells me that it would be a hyperboloid if I could find all 3 of those things. Let's do a couple notes on this. Like last time for the ellipsoid, standard form helps with traces. All right, it's always directed along the axis with the minus. You'll see what I mean when we see the shape for that. All right, and then to help us get some traces and help us graph, we set the negative variable equal to 0 and set negative variable equal to plus or minus the square root of its denominator. This will, we're going to say to get, set those to get 3 traces. Right, the first equal to 0, equal to positive the square root of its denominator, and then these traces will give us those 3, and they'll be either a circle or an ellipse. Okay, let's get an example of this in. All right, so if you were graphing from a homework set, first you got to be able to recognize that it is a hyperboloid. Have a hard time saying it. There is one negative. All right, that was on the list. 2, there was all squares. All right, all the power 2. We'll do this for shorthand for squares. All squares. And then the third thing was that there is a constant term. Yeah, there's a 36. So this is a hyperboloid. Let me make sure I spell this right. Hyperboloid. I may be pronouncing that wrong, but forgive me if I am. Trying my best. So the equation at the above, it's not in standard form. I would really like it to be in standard form, which means that the term on the right side would be a 1. So I'm going to divide everything by 36. So we get x squared over 4 plus z squared over 4 minus y squared over 9 equals 1. So now it's in standard form. Now we follow we take a look at what axis it's along. So it's along the y-axis. All right, and then we get some traces. So let's get some traces so we know what to graph. This will make sense in a moment because you're like, well, cool, along the y-axis, so maybe it looks like some type of cylinder that maybe changes. I'll show you what that looks like with my attempt at a picture, and then also we'll look at an actual 3D graph of it. So the first trace we're going to do is we're going to do y equals 0. If y equals 0, then we got x squared plus z squared. These are still over 4 equals 1. Well, that's just a circle, right? It's an ellipse, but both are perfect. Okay, so we have that trace. Let's go ahead and graph that. I'm going to do that down here. This is on the xz plane, so that's the one coming out at us and going up and down. And it has a radius of 2. So I'm going to plot 2 on each point. Here's this. This will come underneath, and then we'll need dots for the other ones. There we go. Okay, let's go back up. That's the only trace we have there. Now, this was of the denominator. Okay, I know that I have a 3 here. So this tells me I should do plus or minus the square root of the denominator, square root of 9, which is 3, right? Plus or minus 3. So I'm going to plug in both of those. So doing that, it will give me the same answer. That's going to give me an x squared over 4 plus z squared over 4 minus 1 equals 1. If I add 1, then I get x squared over 4 plus z squared over 4 equals 2. Multiplying by 4, we get x squared plus z squared equals 8. So this is, if I take the square root of 8, that's going to give me r, my radius. That's a circle, right? That's a circle. So the radius is the square root of 8. That's, roughly, it's a little less than 3, right? Because the square root of 9 is 3. So r is roughly 3. Okay. So it's a circle with a radius of roughly 3. So let's plot both of those. And we get them in both directions because this was for plus and minus 3. So what does that mean? I'm going to go to plus 3 in the y direction, and I am going to put a straight line there, but I'm going to make it dotted. Go back, I guess I didn't change it. At positive y equals 3, that's right here. I'm going to make a big line. I'm just doing this first to get it straight. I want to make an axis right there that is the same. So now I'm going to do that to get this parallel axis. Doesn't have to be perfect, but I do want to make it look parallel. So there's that one. And then I would need I have up and down, and then left and right is fine. So I still have this axis. So I'm going to change this back to a line and go back to red. Another thing we can do, let me go back here. We can just do these in lines, is I can take this and make it straight here, take a ruler, and make a tick mark here. So this is, it's 1, and then I can actually do this for the other one too. It doesn't even matter what color it is. And I needed to go out 3, so to have a radius that was a little bigger than 3. So I'm going to make my tick marks here. They don't have to be absolutely perfect, but now I have scaling that matches that. It's going to be parallel. It's going to look good. All right, so now I do this. I want to get these scalings, and really all I need is 3, because I know that the radius for this one's going to be 3, but we're here, so let's go ahead and make these tick marks. So those are going that way. All right, and then maybe up and down. Those aren't too bad to see, hard to see, but we'll do it anyway. This one has remember, we're still trying to get a radius of almost 3. That was the square root of 8. Okay, I'm going to mark those. Don't want it to be perfect. Okay, and then I'm going to do it in this direction as well. And this is going to give me a perfect looking one. So, yep, don't know what's going on there. Okay, I got to get a little bit above that one. There we go. So now I have marks in each part. So we're graphing this, if you have forgotten. And that's the square root of 8, which is roughly 3. A little less than 3. So I'm going to go back to red here. And little less than 3. Little less than 3. Little less than 3. Little less than 3 here. And now I draw a circle here. And then I need a dotted on here. There we go. So that's that circle. This line should be gone. I don't know where that came from. All right, so that's there. And then the negative 3, remember we're looking up here. We have this here. That's the plus or minus 3 there. The negative 3 just gets the exact same thing, but moved over. So I'm going to copy this and paste. Sorry for the bird. I am recording outside because it's a nice day, but that bird is here. All right, and there we go. I repeated it over there. You would draw it over. You can pause the video, move it over if you'd like. So now I connect, and we can start seeing what this shape should be. All right, it's very interesting to draw. So I'm going to connect that with here. This with here. This top one gets connected. Oops, switch to eraser. That, and you can kind of see what's happening in there. I'd go back here and do one if I wanted. We could do one right there. All right, we could do something like that. Now we get something like that. So maybe I messed up with that last one. You can kind of tell what it's supposed to be there. It's almost like a tunnel going through a tube, like getting much, much smaller there in the middle. So my drawing on my paper looks okay, better than this iPad one. Let's take a look at the 3D grapher so you guys can see what it's actually supposed to look like. So here's my 3D grapher. Turn my graph on, turn that one on. That's the graph that we're actually graphing, that it should look like. So I think ours is a little more on top like that. All right, so these 3D graphers are great. You can get a real picture of what it's supposed to look like. I would even take, this streams online. You can go to GeoGebra, just Google it, and it'll take you to that site, and you can change the 9s to 5s, and look and see what it does to the graph, and you can start to understand what each part of the graph does.